Very good morning, participants. Before entering to the next session, I will explain about the online test and the validity function timing. So the afternoon 2 o'clock, the starts with the feedback session. So we request all the participants will give a feedback about this AICTE ATAL FDP program. Then it's followed by validatory function. So after completion of validatory function, the online test will start. The timing of online test only 30 minutes. Okay. The total number of questions is only 25 questions. Okay. You can complete and send it to us within 30 minutes. So probably after 3:30, the link will be closed. So before 3:30, all must submit your online test question answers. Okay. If you want any clarification, you can ask me now. Okay. So I repeat that first feedback session. So all the participants are requested to give the feedback about this ATAL FDP, then followed by validatory function, then online test. The online test question only 25. Okay. The time duration is 30 minutes. So probably after 3:30, the link will be closed. So before 3:30, all must complete your online test and submit to us. Okay. Any queries? Please, you can ask me now.
Sir, is it a Google form or any other thing?
Yeah, in chat box at Google, that online test through Google form only. No issues. Only objective type. Only objective type. Only 25 questions. Okay.
Thank you, sir. Thank you.
Okay, if there is no doubt regarding the feedback and the validity and online test, let us start the next session. The next session will handled by Dr. S. Suresh Kumar sir. Sorry, Dr. S. Suresh sir, Professor, Department of Computer Science Engineering, P.A.College of Technology. The title is Machine Learning Algorithm for Big Data Analytics for Smart Grid. So now I welcome Mr. Vinod Kumar to give introduction about Dr. S. Suresh sir.
Good morning, participants. Kind note, at the end of session 3, all are requested to open your Meet camera to capture our memories. So at the end session, after validity, during validity time, all the participants are requested to turn on their camera to take a photo. Now I invite Dr. S. Suresh for this session. Before going into the session, I will give some intro about our expert. Dr. Suresh, yes, is working as a professor in the Department of Computer Science and Engineering, P.A.College of Engineering and Technology, Coimbatore. Previously worked at Adiyaman College of Engineering, Hosur. He obtained his bachelor degree in Computer Science and Engineering from PSG College of Technology, Coimbatore. Master's degree in Computer Science and Engineering, SKP Engineering College, Tiruvannamalai. PhD degree in Information and Communication Engineering from Anna University. He has published more than 25 peer-reviewed journal, national, international conference paper in the field of IoT and big data analytics, AI and machine learning, server virtualization and cloud computing, system modeling and simulation. As a teaching experience of more than 16 years, authored the book C++, .NET programming, published 3 patents, presently guiding 3 PhD scholars. Has in total work in 5 ICMR seminar, AICTE FTPs, AICTE STTP, UGC, SAROMRP, and AICTE MADRA project. Of this project has completed 3 projects and funded by ICMR and AICTE India, and presently working on AICTE MADRA funded project, has fetched funds around 20 lakhs. So his area of interest includes IoT and big data analytics, AI and machine learning, server virtualization and cloud computing, system modeling and simulation. Has delivered more than 15 invited talks across the nation and attended more than 40 workshops, seminars, conferences. Also, he has been a member of technical committee, editorial board, a reviewer in many conferences and journals. So now I welcome Dr. S. Suresh. Sir, now session is yours. Please proceed, sir.
Thank you, sir. Thank you, Vinod Kumar, sir. Thanks for your brief introduction. I first of all would like to thank Vijay Bhaskar, sir, PACT principal, chairman, for giving me the wonderful chance to interact with you all. Guys, faculties, very good morning, all of you. Myself, Suresh. I'm welcoming you all for that ATAL FTP titled Renewable Energy Integration Using AI and Big Data Analytics. And my title is, I'm going to present a machine learning algorithm for big data analytics in smart grid. Can you able to see my slide?
Yes, sir.
Hello?
Yes, sir.
Yes. Hi, hello. So my title is, as I told you, it's dealing with machine learning algorithms for big data analytics in smart grid. So first of all, let me tell you about the smart grid so that the introduction will be much helpful to you, even though you know about the smart grid. Thereafter, I'm going to tell you about what is big data and what is analysis analytics and what is the role of machine learning algorithm for big data analytics. So this is what my coverage. Let's first of all discuss what is a grid, power grid. So power grid delivers electricity from a power plant to your house. However, what is smart grid? Whenever smart comes, it should be replaced with the terminology intelligence. Intelligence, also known as smart. So yes, what is smart grid? A smart grid is said to be an electricity network enabling a two-way flow of electricity and data with the digital communication technology enabling to detect, react, and proact to changes in usages and multiple issues. Smart grids have self-healing capability and enable electricity customers to become active participants. What is the role of machine learning in the sense and AI in the sense? Machine learning and AI can enable smart grid to make intelligent decisions and respond to sudden changes in customer demands, power outages, sudden drops, and rises in renewable energy output or any other catastrophic events. So machines can learn the data algorithms responsible for causing faults in the system and use this information to identify problem before they use. So whatever the data that we are collecting from this smart grid that can be analyzed by using a machine learning, and it will help to take the useful decision. Say for an example, peak power demand. So machines can learn the data. That's what machine learning. Machines can learn the data and algorithm responsible for causing faults in the system and use this info to identify problem before they use. Manufacturers can make use of ML to improve maintenance process and enable them to make real-time intelligent decision based on data. So grid, smart grid, because smart grid involves digital equipment that not only send the data, that is capable of sending information also. Once if the, yes?
So slides, we are not able to view the other slides. We are able to see only the title slides, sir. Please check it out, sir.
Okay. Well.
Yeah, thank you.
So, so from the data, what we can do is we can do the analytics activities. So machine learning is helpful to do that. So I'm going to tell you cover three areas. One is what is big data analysis, big data analytics. Afterwards, I'm going to tell you about what is machine learning, why one would need it, what are the various type of machine learnings are available, and a little bit introduction about Google Colab, because using this, you can do this machine learning algorithm implementation by using Python languages. For is a free platform, Google Colab. I'm going to give you introduction. Then I'm going to teach you about the case study. Actually, I have to implement the case study by using a smart grid power related data set only. But for the sake of simplicity, I'm going to take some medical data set, and going to illustrate how you can apply analytics activity using machine learning algorithm. Okay, this is what my coverage. So before we proceed, we should first of all know about what is AI, because this machine learning or whatever it may be, the new evolving technology is a evaluation technology from the AI only. So what is AI? Artificial intelligence. Artificial means synthetic. human imbibing, right? Intelligence, the ability to learn and to understand. So artificial intelligence in the sense, giving the ability to the machine such that it can, synthetically we are giving the skill set to the machines such that it can be able to learn and understand, to act rationally. So this is what the big domain artificial intelligence comes. Machine learning is part of the or subdomain of artificial intelligence. Okay, first of all, we should first of all know about what is big data. Actually, data everywhere is there. A lot of data are there. Because of the digital era evolvement, what happens in the sense, a lot of data keep pouring. So massive set of data keep coming. So what is big data? Whenever the data size is greater than 20 GB of data, then the data can be said to be the big data. So this data comes from n number of sources that is given here. See, 204 million emails sent, photo views, hours of music, tweets, Facebook logins, Google searches, Flickrs, everything, right? It comes petabyte of data, exabyte of data. Merely the data is not sufficient. You need to do the analysis activity, analytics activity, so that you will get the knowledge. Sir, can you tell me some examples for what is analysis analytics? In cricket, you can see like sometimes whenever the match happens, they used to put as follows. Like whenever India bat against South Africa or Australia or New Zealand, and whenever it scores more than 260, and under Captain Dhoni's captaincy, and whenever he scores more than 50 runs, there is 90% of possibility winning. So how it is able to fetch such a knowledge from the data? So this is what machine learning comes. So when the data is too big, it is said to be the big data, and the machine learning algorithm capable of doing this big data analytics. So traditional algorithms like data mining is not capable to do analysis for this much of big data, particularly when the data is real time, spontaneous, on go data set. Okay, so what is big data? You get the point about what is big data. Big data has plenty of characteristics that can be unstructured or structured, and it can be in motion also. Data at rest, these sort of characteristics it consists of. Data in doubt, whether it is a structured or unstructured, completeness, this sort of special type of characteristics that big data consists of. There are plenty of technologies are already used in the previous cases. Say for an example, data mining to analyze the data to get the knowledge. However, as the data size becomes very high, a zettabyte of data, the traditional machine traditional algorithms not able to do this analytics activity. That's why we have to go with the machine learning. We are going to discuss about the machine learning shortly. Before that, so there are plenty of machine learning algorithms that helps to do the big data analytics. When you want to do that big data analysis, the first part, this is the phases actually. Get the data and clean the data, that is unwanted things to be removed, and integrate all the data, do the analysis and do the interpretation. Analysis means very simple, visual representation of the given data. So in cricket match, you have seen like that scoreboard, right? That is a very good example for analysis. And the run rate comparison, that graph is a very good example for analysis. Analytic means what it has to do is it has to fetch the knowledge. Particularly, I that statement, whenever India plays against New Zealand under Dhoni captaincy and India scores more than 260 in the pitch, there is a 60% of winning, 80% of winning, 90% of winning. This is what analytics comes. So where the big data analytics plays a vital role. Analytics, it helped in plenty of areas like business intelligence, decision support, predictive analytics, governments, healthcare, research, marketing strategy. Very simplest example is in Corona, they guessed in the third phase will probably come in October or November of 2021, but that didn't happen. But we expected, right? So this is what the example for analytics. So where does big data come from? It comes from plenty of areas. So look at this, various areas where the big data comes from: enterprise, public, commercial, social media, plenty of places, sensors, industry, weather prediction, population, email, and so on. These are all said to be the big data. That is massive amount of data having 4 characteristics. Particularly these 4 characteristics, it consists of volume, velocity, variety, veracity. These characteristics that should consist of. So the big data opportunities, what it can do once if we analyze analytics, if you do what it can give in the sense making better informed decisions, discovering hidden insights, automatic business processes. These are all very simplest example for this big data opportunities. If you go for analytics, discovering hidden insights, anomaly forensics, patterns, trends, making better informed decisions, strategies, recommendation for business, for healthcare related things, right? This is what the big data opportunities. So very simplest example is identifying insurance fraud is one of the example of this analytics. Insurance. So whenever the customers do any insurance related thing, what we can do is we can identify from the data set that whether the particular customer is a good customer, bad customer. He is doing a right thing or a wrong thing. His claim is right or wrong. That sort of analytics we can do this, so that it helps for the people who are all involved in this insurance related thing. Similarly, one more example, let me tell you for analytics using machine learning algorithm. See, look at this. What McDonald's previously does in the sense, they used to check it out, the bun quality, seed distribution, everything manually, right? Then they need to change certain parameters if it is wrong. However, by using that machine learning algorithms, doing the analytics, what they can able to do is they can automatically, it can do the processing. Like from the photo analyzer, it can tell you whether the bun is in correct thing, the seed is distributed, bun is correctly prepared and everything. So because of that, they can eliminate thousands of pounds of wasted product per year. So speed production is possible, saving energy possible, reducing manual labor cost. These are all very simplest example for machine learning as well as data analytics. So pay special attention to this slide. See, it consists of what is analytics. Analysis means whatever data available that is presented in a visualization mode, exactly as it is. That is what example for analysis. I told you simply cricket board score comparison, right? Summary of that end of the match. Those are all very good example for analysis. However, analytics in the sense is the systematic computational analysis of a data or statistics. It is used for the discovery, interpretation, and communication of meaningful patterns in data. It also entails applying data patterns towards effective decision making. See, there are 4 type of analytics are available. Analytics. First one is the descriptive analytics. It can able to tell you what really happened. So it's a very simplest example. We can take a cricket match in which if you give the data, then it will tell you who won the match. Description, what happened, who won, who failed. Then second one is the diagnostic analytics. If you give the data, then it will tell you why it did happen. Say for an example, if you give India score sheet, scores, then obviously it will able to identify why India failed to score. That's what a diagnostic analytics. Why did it happen? Why India failed? So this is what the reason. It can calculate from individual score and team score and so on. What will happen? What will happen? This is a type of analytics that also possible if you give the data. So if you give the data of last 5 years data to this machine learning algorithm for data analytics, it is capable to tell you predictive analytics. Who will win? Will India win? It will tell you what will happen. That's what predictive analytics. Prescriptive analytics. How can we make it happen? India is not winning the match. How can I make it to happen? So obviously it can tell you, do this replacement. We need some more seamers, bowlers. We need a good captaincy. These are all the lagging area that we are having. And if you do the changes, then possibly we can win. Okay. So predicting score also. Sometimes you can see in the cricket board, it will tell you if the run rate is 8.6, then the expected score is 169. If the run rate is 10, the expected score will be. These are tough things it will predict. No, this is what all the major aim of analytics. So what we are discussing is, we are discussing big data. What is the importance of big data? What are the characteristics of big data? Where does the big data comes from? And what is analysis? What is analytics? What is big data analytics? This is what I covered so far. So you can see the descriptive analytics. See, merely whatever the data you are coming, if it is given in the visualization format, right, well visualized format, then it can be said to be the descriptive analytics. Suppose if you go for some other run prediction, then that can be said to be the predictive analytics. In cricket match also they used to give the score prediction level, no? Okay. Next, prescriptive analysis. This is a high level. This is high level prescriptive analytics. You can see here. See, prescriptive analytics, foresight, insight, foresight, toughest level. So it will tell you that resources, how to effectively utilize the resources. It will tell you to attain certain aim or objective. That's what prescriptive analytics. Okay. So I have completed that what is big data. Next, let us move on to machine learning algorithm. What is machine learning algorithm? Let's see. So what is machine learning algorithm? Okay, so this is I'm going to cover in this machine learning. Have you ever wondered how self-driving cars work? Netflix recommends the movies, Amazon recommends your products, Google search gives you such an accurate result, speech recognition in your smartphone. These are all some of the examples. Generally, we wonder, but all the technology that behind the scene is, name it as machine learning algorithm. So what is machine learning algorithm? You should once again know about what is artificial intelligence. Artificial intelligence in the sense, you are giving a skill set to the machines such that it can be able to learn and understand, so that it can act rationally. So this is what major aim of artificial intelligence. Machine learning algorithm is one type of the big domain of artificial intelligence. What is machine learning? The motivation behind machine learning is getting computers to program themselves. Let the data do the work instead. Era of thinking machines has arrived. We want to make the machine to be intelligence and automated reasoning. What is machine learning? Let's see. What is machine learning in the sense? Before that, let us discuss about some more thing. If I ask you a question, how you are getting the skill set to differentiate male and female? How you are able to distinguish dog with pig? Then you will see, sir, from the childhood itself, we come to see a plenty of images, and our system start learning about the futures of pig, dog, human, man, male, female, everything. We start to learn from the images, and we identify the futures. So at later part, what we can do is we can able to easily distinguish what is dog, what is pig. So day by day you start learning from the data, that is photos, right? And you distinguish the futures, how dog futures differ from pig future, male futures differ from female future, and so on. So this is what the motivation behind machine learning. So machine learning is a technology that can able to learn from the given data, and it can program itself. It will identify the model. If you give the data, say for an example, if you give a machine learning algorithm n number of images, that is male images, then you can, if you give some other testing data set to check it out whether male or female, what it will do is it will correctly identify whether it is male, whether it is female. Why? Because this that machine learning algorithms capable of learning from the existing data set, identify the futures, and later on it create a model, so that whenever you give any other testing data, then it can easily differentiate. So this is what the thing. If you want to manually write a software, it is a very cumbersome. Why? Because you need to write everything manually. If these are all the features available, then it is a dog. If these are all the features available, it is pig. If these are all the features available, it is a male. If these are all the features available, then you need to distinguish it is a female. Then you need to do the pixel by pixel comparison, which is a very toughest job. So what is the revolution happened in the sense from information revolution to intelligent system revolution comings? That's what smart camera, smart robots, smart cars. Whenever the word smart comes, it means it should be replaced with intelligent. Intelligent means the ability to learn and to understand. Smart robots, the ability to learn and to understand means that if any obstacle comes, it learns there is obstacle and move ahead. Okay, smart cars, it moves whenever it identify any pedestrian or any other cars approaching itself, it stops and take another direction. So these are all the thing behind machine learning. Okay, what is machine learning? Machine learning is an algorithm, a discipline, enable the computers to learn from data and even improve themselves without being explicitly programmed. So what we are discussing so far in the sense, I first of all said what is grid, what is a smart grid, why one would need it. From the data available from the smart grid, using machine learning algorithm, you can do the analytics. From the analytics, you can take better decisions. And I said what is artificial intelligence, and I said what is big data, how it differs from current data, what is the need of machine learning, what is the problem with the data mining, I said. Then we discussed about what is the difference between analysis and analytics, we discussed. Then n number of analytics, 4 type of analytics type we discussed. And currently we are in machine learning. So what is machine learning? Machine learning is a technology. Machine learning algorithms enable the computers to learn from data and even improve themselves without being explicitly programmed. So this is what you should understand. I'm going to give you one example so that you can easily understand what is machine learning. Machine learning is a category of an algorithm that allows the software application to become more accurate in predicting outcomes without being explicitly programmed. You can see like ordinary system with the AI, right? AI machine learning, what it can do is it can learn something from the data. Thereafter, if you want to check anything, or if you want to make your machine learning to identify, predict, right, then it can do that. So using algorithms that iteratively learn from data, machine learning allows computers to find hidden insights without being explicitly programmed where to look. This is a very simplest example, tells you about what really machine learning algorithm means. Traditional programming methodology. Traditional programming methodology, you have a data and you need to write a program, and so in the computer, once if you compile the program, run the program, and if you give the data, the output would comes. But machine learning, what it does, you can simply see this. Computer is there. What you need to do is you need to give the data. You need to give the data, and what output you are expecting, that should also be mentioned, and it will give you the program. Okay, let me tell you once again. Suppose the machine learning algorithms is there, right? If you give 0, 1, 1, 2, 3, 5, 8, 13, what it will identify in the sense, it will identify the hidden pattern in this given data is Fibonacci series, so that it will create a model, Fibonacci model. This is what I'm telling, learning from data. If I ask you, give you this number and ask you, what is this? What is the relation between this? Then you will tell you, sir, actually that given data is none other than a Fibonacci series. Then you can ask another question. What is the next term comes? Then the computer will easily say. What is skipped from the traditional programming in the sense, you are not writing the program. Because data only you need to give, and the output that you are expecting you need to give. It will create a model. From the model itself, it will predict for future. Okay, so learning models from a data of particular example. Say for an example, customer transaction to consumer behavior. Okay, this is very important slide. So what is machine learning? Machine learning in the sense, enable the computers to learn from data, because this is how we do, and even improve themselves without being explicitly programmed. There are a number of algorithms are there. You can choose any of the algorithm depending upon your problem type, and you can apply, it will do it for you. What are all the areas machine learnings are used? Prediction, image recognition, speech recognition, medical diagnostics, financial, industry, and trading. Very simplest example, medical diagnosis. Suppose you are doing a brain image, right? Brain image you are having. Suppose already your program is, your machine learning is trained with tumor related brain images. Then if you give the new image, it will tell you whether the particular tumor is available in the image or not. So this is what machine learning does. So you need to give the data first. From the data, it identifies the future of your related problem, and later on if you give any other images, it will identify because it has already learned. No, okay. Prediction, loan example. So from for loan also they are using these sort of algorithms. It will tell you whether the customer is good or bad, whether he is eligible to give a loan or not, but you need to give the data. So what are the various type of machine learning algorithm? In the sense, broadly it is classified into supervised, unsupervised, reinforcement learning. Supervised in the sense, learning algorithm from the training data set, that is a labeled data set you need to give, right? So your machine learning algorithm will learn the futures from the data, and it is capable to solve the following problem: classification problem and regression problem. Regression problem in the sense, score prediction, no, that is a very good example for regression. Classification in the sense, image classification is a very good example for supervised learning. Don't forget, machine learning algorithm consists of n number of algorithms. Depending upon the problem, you need to choose which algorithm will work for it, and you need to adapt it. Unsupervised learning means modeling the underlying or hidden structure or distribution in the data. So when you give the data, the data need not to be a labeled data. I will give you an example so that you can easily understand. So it can be able to understand the hidden structure. Very simplest example is clustering is a problem it is capable to solve. So for an example, a biology cells, blood cells you are having, right? If you give, it is capable of a cluster related to type. And dimensionality reduction also one type of problem. Sir, what is dimensionality reduction? In the sense, data that you are getting, no, if it consists of n number of features, then that is n dimension. But working with the n dimension of data is very tough. 2-dimensional, 3-dimensional, 4-dimensional, n dimensional data that we have already studied. No, images are a very good example for 2-dimension. Okay, videos are an example for 3-dimension, and so on. There are plenty of problems are there that have 10 dimension, 16 dimension, 20 dimension, 100 dimensions of data. So you cannot straight away work with a 100-dimensional data. System will hang. So what you can do is you can try to reduce the dimensions. This unsupervised machine learning algorithm capable of doing the dimensionality reduction. One example is face recognition is a example for dimensionality reduction. Another type of machine learning algorithms is a reinforcement algorithm. So what's this in the sense? Particularly games you can see, like a lot of games are there that will chase you. A car game is there. All other games, robotic games are there, and one more game is PUBG, shooting games. Such games are there. So n number of players will be there. You are also one of the player. The system has to identify what's going on around the environment, and it has to act accordingly. So reinforcement learning is a type of machine learning algorithm. It identifies how software agents ought to take action in an environment in order to maximize the notion of cumulative reward. Example is robot navigation. From the environment, it has to identify whether it can move this way or not. Okay, so that's what reinforcement. Let us see example for each and everything. Supervised learning. AI system is presented with the data which is labeled, right? Two sort of problems supervised learning able to solve. One is classification. Look at this. Suppose two type of data that you are giving, then supervised learning able to distinguish it. provided it should be given a data. Already you should have given the labeled data to this supervised machine learning algorithm, and once if it learns, created a model, then it will identify these are all red, these are all green. Similarly, regression problem, that is core prediction. What you can do is that supervised learning will be able to identify. This is where, look at this training data, future vector, and algorithm model is created. Once the model is created, then you can use it for prediction or classification or regression activity, anything. That's what learning phase. Training data, futures, you need to identify the future. It identifies the futures. By using appropriate machine learning algorithm, it create a model. Very good example is already I told you, no, this one. 0, 1, 1, 2, 3, that input if you are giving, then the machine learning algorithms start learning the model. What model it creates, it comes to know about is the Fibonacci series. If you ask about what is the next term that you are expecting, in the sense it will tell you the next term. A very simplest example for supervised learning, in the sense, suppose your machine learning algorithm, your program algorithm software, if you are giving spam and not spam mail, initially it learns spam type of mail, in the sense it consists of the following feature. Not spam, in the sense it consists of the following features. Then which are all the mail later comes, then it will distinguish. So learns, and a model is created. If you test with the new mail, because already it learned not spam mail means it consists of following feature, spam mail means it consists of following feature, so it can categorically separate. It is not spam, it's a spam. This is the logic behind the Gmail notification. The particular mail seems spam. Would you like to open it now, or let me send it to trash? Do you get the idea? So this is what a supervised learning. Okay, see, the data can be any type, that can be an image, or like this, say Excel sheet. It consists of this sort of rows and columns of data. Suppose a data is given. See, look at this loan application data I have shown you. You should first of all know about what is each and everything. This is a record. This row, no, record. Set it to be the ID 1 is a record. Age, has job, own house, credit rating, all are attributes. And class, in the sense, this is the output. This is the output. This is set to be the future. Age is a future of this loan record. Has job is a future. Own house is a future. Credit rating is the future. And these are all the values for the particular record. So data, in the sense, all the informations are set to be the data. This is set to be the label. This output, no, it is set to be the label. So how many future it consists of? This loan application, 1 future, 2 future, 3 future, 4 future it consists of. This is output. This is output that we are expecting. So if you give it to this machine learning algorithm, it will identify the that hidden pattern within that, and it creates a model. Okay, so label, data, information, ID, everything. So we are going to do one case study. At the time, you come to know about what it all are. Next, labels and labeled data for this one. See, look at this. If 3 sides, it is triangle. If 4 sides and all sides are equal, then it should be a square. Hexagon means this is the property you are giving to the machine learning algorithm, right? Labeled data you are giving to the machine learning algorithm, and it identifies. Square means this feature, triangle means these are all the feature, hexagon means these are all the features. Then create a model. Then if you check with some test data, it will predict which is square, which is triangle. Okay. Next, unsupervised learning. A very simplest example for unsupervised learning, in the sense, in temple they are using a undial, right, in which coins, notes, 5 rupees, 1 rupees, 3 rupees, for 5 rupees, 10 rupee coin, 10 rupee note, 500 rupee note, these are all available. You need to segregate it. That's what a clustering. Similarly, what the system will able to do is that unsupervised machine learning capable of cluster depending upon your problem. See, particularly example, grouping customers by purchasing behavior, right? Clustering example. Association, Very simplest example is whenever a person buy a shoe, possibly he will buy socks, right? Then shoe brush, he will probably he will buy. That sort of association activities problem also can be solved by unsupervised learning. Here also data is needed, but then data need not to be labeled. Or it's a small example, a simple example. Look at this data that we are giving to this unsupervised machine learning algorithm. See, look at this, some features for this Donald Duck and Mickey Mouse. So when you give, what the system will do is, it will identify the feature, duck, 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 Mickey Mouse, Mickey Mouse. Okay, so already no labeled data is given. Previously we have given labeled data, but here didn't give labeled data, only data is given. It knows how to cluster it. See, look at this, it has clustered ducks and non-ducks. So this is what difference between supervised and unsupervised. Reinforcement learning, particularly in robotics, it is plays a vital role. In all games, reinforcement learning comes. What is reinforcement learning? It's a agent, software agent, learns by interacting with its environment. See, look at this. Here, this is its starting place. It has to go here. It has to go here. But what it has to do is, it start moves. It comes, goes here, and learns there is no path. Then come here. Then come here. Come here. Here go. It said no. Output is not identified. So go here. Is there possibility? Yes, reached. So whenever it makes a move, it identifies whether it leads to solution or not. At the time itself, it will identify and update its information. Let me tell you one more very simplest example. What is reinforcement learning? See, elephant that is trained by using reward and punishment system. It has to do something, right? Give asirvada, and it has to dance, such a things. How they are training? They force the system to force the elephant to do a certain thing. When it do correctly, they are providing banana to eat something. That is a reward. Whenever it not budge, then it is punished with the lashes. So from this, the system come to know about, elephant come to know about from the environment. So if our master says something, we need to do it correctly. If you don't do it correctly, that punishment will be given. This is what the reason behind this reinforcement learning. See, all the game related things, the agent learns the environment and act accordingly. Chess games also very good example. One side you can play, another side that machine play. How does it come to know? From the board, it comes to know about what is the movement that person has done and what is the movement it has to do. If it makes any wrong moves in the near future, it will learn not to repeat the same future. So that's what state movement and rewarding system. The agent receives rewards by performing correctly and penalties for performing incorrectly. Trains algorithms using a system of reward and punishment. So tell me two places, robot navigation and the games are the very simple example. So look at this. This is a very simplest example for that reinforcement learning. What the robot need to do is, see, there is one thing is fire, another thing is water. The robot initially doesn't know. It's equivalent to child only. The child start learning whether it is a fire, it harmful to our body, water, not a problem. Then later on, it ever touch this fire. That's what they are telling. Learn from environment. Initially, agent is there, robo. When it touches fire, it comes to know about it's a wrong. So it made a wrong move. So its cumulative reward is reduced with the 50 points. So it identifies it's a bad. That movement should not be done in near future. In this way, it start learning and going to the goal. So this is the comparison between supervised and unsupervised reinforcement learning. There are plenty of machine learning algorithms are available. Plenty of machine learning algorithms, varieties of types also available. But some of the algorithms are frequently used. Let us see about the very simplest algorithm. So based upon which methodology it uses, it can be classified into N type. Neural network is one type of machine learning algorithm. Then regression, clustering, dimensionality reduction, decision trees, Deep learning also a type of machine learning algorithm. Ensemble, rule system. There are plenty of algorithms are available. We are going to see a very simplest algorithm, linear, non-linear algorithm. Say for an example, suppose your problem is binary classification problem. Binary classification problem. Say for an example, from the particular data, you are interested to identify whether the person is affected by sugar, right? Then that can be set to the binary classification problem. Suppose your data consists of three multi-class classification. Then you can go with a special type of algorithm, name it as linear discriminant analysis. Logistic regression, linear discriminant analysis. There are plenty of other algorithms also available. K nearest neighbor algorithm. It used to identify K most similar instances using a distance metric. There is another algorithm is available, name it as naive Bayes, which works based on probability. So calculates the probability of each class and the conditional probability of each class given each input value. For binary classification problem also, you can go with the naive Bayes, right? Classification regression tree, CART, or just a decision tree, construct a binary tree from the training data. Support vector machines. So it seek a line that best separate two or more classes, right? Using kernel tricks. That is one of the technique. Okay. So this diagram is telling you your idea about how, when you have to choose a regression algorithm, when you have to choose a dimensionality reduction, when you have to choose classification algorithm, when you have to choose clustering algorithm, and so on. Okay, depending upon the samples, problem types, you can go with any of the data. Okay, before we are moving to hands-on machine learning using Python, I'm going to first of all give you introduction about that platform freely available so that you can program it. So for an example, suppose you want to do machine learning program using Python, then obviously you need good system setup, as well as you need Python should be installed and machine learning packages to be installed. But if you go with the Google Colab, that is everything is installed. If you want to do machine learning activities, if you want to do computer vision activities, everything can be done with this Google Colab. It is a free cloud service and it supports a free GPU. N number of GPU it provides. Then Colab is a free Jupyter notebook environment that runs entirely in the cloud. Okay, so let me open a Google Colab. How does it look like? So look at this Google Colab. If you type Colab, then automatically you are getting Google Colab. Google Colab. And click Google Colab. Then if you want a new notebook, file new, you can create a new notebook. So look at this. What you can do is here you can write your code, and if you click here, then it will run. Okay, so you need not to worry about whether your system is poor, not enough RAM is available, hard disk is available, not platform supported. Such a things you need not to worry. You can straight away go file and you can save your things here. You can easily include the data here. Okay, I'm going to tell you. Okay, so we have studied a little bit about, I gave you the introduction about what is grid, that the power grid, what is smart power grid, then what is machine learning algorithm, why we need it. I explained what is the application of machine learning algorithm in smart grid. We discussed. Later, I gave you the example about big data. If the data size is more than 20 GB of data, then that can be said to be the big data. and the traditional algorithm not capable of to work with a huge amount of data, because big data have special properties, data in doubt, variety, velocity, and so on. So, and we discussed about analysis and analytics. Analysis means visual representation of the given data. Analytics means identifying the hidden patterns between the data, because scientists have identified the following thing: that the data itself consists of future prediction. Data has consists of all the details. If you do the statistical activities, it will tell you what is the future, what will going to happen. So that's what analytics does. Four type of analytics we discussed: diagnostic, predictive, prescriptive analytics, descriptive analytics. Everything we discussed. What is the difference between analysis and analytics we discussed. And later on we discussed about what is machine learning. Machine learning is a type of program, it's a type of technique. It's a aim to learn from the data, and you need not to write everything from the scratch, and it avoids writing a program from the scratch and try to learn all the relations and create a model from the existing data set. What is the three type of machine learning we discussed? Supervised, unsupervised, reinforcement learning, such a things we discussed. Later we discussed about some of the machine learning algorithms like linear discriminant analysis, logistic regression. There is a linear regression also available. Bias classification algorithms we discussed. Dimensionality reduction we discussed. SVM we discussed. Similar thing we discussed. Later on I told you about, if you are interested to do any project and want to run in a free cloud environment, then your Google Colab will be helpful, right? So first of all, you should know about any of the Python, any of the language, so that you can easily program. Now I'm going to tell you about one of the best programming language, which is open source. It consists of n number of built-in packages. So if you want to do any machine learning related activities, then you can straight away go with the Python. Not only Python, Java also there, other languages also there to do the machine learning. But I recommend it because experts says is a popular language in general, consistently appearing in top 10 programming languages. Then widely used for machine learning and data science because of extensive library support, and it is a general purpose programming language, unlike R and MATLAB. MATLAB also supports machine learning. There is another statistical package is available, name it as R, that also useful. But if you know C, C++ itself, if you want to learn straight away, you can go with the Python. Okay. See, there are some packages are available that need to be used before you do the computational related activities for science and engineering, mathematics, as well as for machine learning algorithms. One is named it as SciPy. It's a Python library for mathematics, science, and engineering. It consists of following packages like NumPy, Matplotlib, Panda. One is for working with array and 2D charts, as well as for organizing and analyzing the data using data structures. Skitlearn is supporting machine learning algorithms, so you need the library also. So Python crash course, nothing new from the previous languages like C, C++, Java. It doesn't have open brace, closed brace, and some formats differs. It use indentation, right? Okay, assignment, flow control, data structure, functions, or something that you need to study about the Python crash course. See various ways that you can do the assignment: flow control, if, else, while loop, for loop, and so on. Data structures like dictionary, list, tuple, it supports. So you should know about the basic functionality, how it syntax representation. Then only you can start doing the machine learning related activities. So writing the function also one type. So I'm closing this because Python, if you know the C, C++, that is sufficient to proceed with Python. Now I'm going to give you the case study. What I'm going to do: hands-on machine learning using Python. Now it's the time to dirt our hands using some simple project. I'm going to tell you do a small project case using PIMA diaptase dataset for classification problem. Classification in the sense is two classification problem. I'm going to take a diabetes patients, around 136 record or 200 records are there. I'm going to initially give it to this machine learning algorithm, and it will identify in order to be a patient, diabetes patient, what are the characteristics are there. In order to be not to be a diabetes patient, what are the characteristics should be there. It starts learning the model. Thereafter, if you give any data like new record, new patient record, it will tell you whether the person may consist of or may not consist of diabetics. Why I'm choosing this data set in the sense is widely used and straight away it is available. Okay. So because time is limited, let me run and show you the output and the phases involved in the machine learning project development. So you can see the data straight away. Look at this. Here is the data. This is the data. You can ask me the question, sir, what is future? See, 6 is number of times pregnant. Second data is plasma glucose concentration. Third one is diagnostic blood pressure. So it consists of 8 futures. PIMA data set consists of 8 futures and 1 output. That's what class variable. So 1, 0. 1 means he is a diabetic patient. 0 means not a diabetic patient. So this is one record. This is one record. Okay, this 50 means age. Diabetics pedigree function 0.627 and so on. How many data are available in the sense? Around 300, 400 data are available. So already I told you these are all the futures. These are all the futures, right? And the futures are number of times pregnant, plasma glucose, diastolic blood. These set of things are all available. Okay, let's do a simple project. A programming activity consists of the following subphases: understand data with the descriptive statistics, understand data with the visualization, pre-processing the data, future selection, resampling methods, algorithm evaluation metric, spot check classification algorithm, model selection. First of all, you should choose the data and you need to do the descriptive statistics. In the sense, how many data are available, what are the data, what is the relation with one data and another data, and pre-processing the data. Some anomalies is there in the sense you have to fix it, and how the data are related with one another you have to see manually, so that you can do the processing activity and preparing the data. If any of the data are missing, you should put null value, or that's said to be the future engineering. Next, not all the futures are decides the output. So certain data sufficient enough, you can ask the machine to identify which are all the future selections are needed. That's what preparing data. Then resampling methods. So suppose you are having a data in the sense, you need to divide into 2 types. One is train data and another one is a test data. What are the various way you can train your machine? How the samples can be taken? Is it advisable to give all the data altogether or shuffle the data altogether? Then which metric will tell you the my developed machine learning algorithm works better? So that's what evaluation metrics. Say for an example, accuracy is the very simplest metric that will tell you how good your prepared model is. Then n number of classification algorithms are there. One is naive Bayes, SVM, logistic regression, LDA, linear discriminant analysis. The plenty of algorithms are there. So you can use n number of algorithms and you can see the accuracy. It will tell you which algorithm works much better. Then you can choose the appropriate model. So define a problem is the first phase: analyzing the data, prepare data, evaluate algorithms, improving the result, presenting the results. So let us go, is the time, so that straight away we can go to this program. Already I have developed and executed everything because the time limit. So just to see the output, how it is, how it works. So first of all, we have to pick up the data. Already I showed you a data, no? That data is saved. Its name is Pima Indians diaptus. Pima Indian diaptus. You can see like I can inherit the data. I have taken the data. Once again, you also see the data so that you will get some idea. See, look at the data. Future, 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 class type. Data, you can see this. Data are readily available. So if these are all the future it consists of, then it's not a Pima diabetes patient. It's a diabetic patient and so on. Okay. So data is uploaded. Then first action that you need to do is understand your data with the descriptive statistics. If you want to see your data, you can straight away pick it. If you want to see the dimension of the data type of each attribute, descriptive statistics, if you want to see the class distribution, correlation between the attributes, skew of univariate distributions, everything you can see. See for an example, suppose how many data are there? 7, 6, 8 data are there, 9 columns are there, 8 future, 1 output. Next, if you want to see some of the data, you can do this. This is a code. If you click here, then it will produce the output. So after, as a software developer, when you do your program, these are all the things you need to do. So only you come to know about the data, right? Next, data type of each attribute. So look at this, that one is integer, another is a float, another one is objects. This data. And the descriptive statistics you can see. It is capable of giving like count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, maximum value. Everything is there. See, it gives. That's what a descriptive statistics. So that if you come to know about all these things as a future engineer, you can take the particular action, right? If any data is missing or not, whether the particular data future decides the output very much or not, such a things you can see. Like class distribution, how many classes are there? Only 2 classes are there. One is diabetic patient, that is 268 records are there. For non-diabetic patient, that is 500 records are there. That's what class distribution. You can see the code here. Relationship between 2 variables. That relationship between 2 variables also you can see by using Pearson statistics. What it will tell you in the sense how PREG, the particular character, particular future, PREG, related with plasma, PLAS. You can compare this PREG with 0.141. It is differs. In the sense, if it is increase, this is also increase. However, look at this pre with skin. Whenever it increases, it decreases by minus 0.082. Whenever PREG increases, test decreases. So this is what the relation it shows. Skew, also a type of refers to distribution that is assumed is shifted in one direction. Okay, now everything we discussed in theory, let us see the image related analysis. So that is generally said to be the univariate plot and multivariate plot. What you can do is from the data, you can see like how that particular features are distributed and so on, right? This is said to be the univariate plot. Univariate plot means histograms. Group data into bins and provide you a count of number of observation in each bin. See, look at this, the data. Some data you can see like looks like bell curve. See, look at this bell curve. That's what a Gaussian distribution. This is exponential distribution. This is not. Okay. Next, univariate density plots. So what is the difference in the sense? This is bin diagram. However, it's a smooth curve. Both are same only. Next, what you can do is you can see the 25th percentile, 75th percentile, outliers, everything can be seen with the help of box plots. So for our data, it shows the box plot. This is a mean, 75th percentile, 25th percentile. This is outliers. Next, correlation plot gives an indication how related the changes are between 2 variables. So this diagram clearly says how PREG related with all other. If it is yellow, then straight away directly proportional to this 0.5, in the sense only this much level only both the preg and other attributes related with. Scatter plot shows the relationship between two variables as dots in 2 dimension, one axis for each attribute. See, look at this scatter plot. Okay, suppose if you don't understand any of the thing, means don't get worried. What I am teaching you is, I have taken a particular case study of Pima Indians diabetes data set. I am going to develop a machine learning program, a machine learning model I'm going to develop. Before, when you create a machine learning model, there is a plenty of n number of steps are there. One is understanding your data with the descriptive statistics, because you need to understand how your data looks like. Then understanding your data with visualization by using visual representation. The third thing is you should know about prepare your data for machine learning algorithm, because you cannot straight away use a data. Why? Because some data may consist of a text. The system doesn't know how to process the text, so you need to do that. Suppose some of the record may is incomplete. At the time you need to fill the missed data with values. So those are all you need to do. Then you need to standardize the data, normalize the data, rescale the data depending upon application or which machine learning algorithm you are going to do. Let us see what is prepare your data. Prepare your data for machine learning. Rescaling the attributes to all have the same scale, 0 to 1. Particularly some algorithm like regression neural networks need this sort of scaling. So these are all the code. Min max scalar will do the work for you. Okay, so look at this. We saw some values like 65, 73, but all the data here are like 0 to 1 only. That's what rescaling the data. Then standardize the data. Standardize the data means mean 0 and standard deviation 1. In this way, it creates the data into Gaussian distribution. Gaussian distribution. You can see this here. Next, to normalize the data. So normalization in the sense rescaling each observation, that is each row, to have a length of 1, called a unit norm, or a vector with a length of 1 in linear algebra, right? This is done by normalized x scalar dot transform. Normalizer fit and transform method we are using. So straight away all the things are used. So only you need to know the function only. So you can see this, how does the output look like. Next, binarize the data. Binarize the data means depending on certain threshold, for some threshold value, whenever that record maximize the particular data, it is set it as a 1. Whenever it lesser than particular threshold, then it is set to be a 0. See, look at this, 1 and 0. Transform the data using a binary threshold. Okay, now 3 activity we completed. 4th activity is future selection. What is future selection? I already told you what is future. See, look at this. First future, second future, third future, fourth future, fifth future, sixth future, seventh future, eighth future, output class. First future name is number of times pregnant, plasma glucose concentration. Third future is diastolic blood pressure. Okay, we discussed, no? So in this, one thing you should first of all know, not all the futures going to decide the output class 1. Some of the futures straight away are highly correlated with the output class. Say for an example, suppose in this record your name is there. Will it going to affect the output class? Definitely not. So this is what choosing the appropriate futures. There are plenty of methods are available: univariate selection, regressive future elimination, principal component analysis, and so on. Let us see these 2 only. Okay, so there is a chi-square test is there, and there is a package is available, select k best. By using that, what you can do is you can tell the machine to use the following statistical procedure and identify which are all the input future, that is which column decides the output very much. Here it will give you the idea. See, first future decides 111.52 level. Second future decides the output 1411 level. This is 17, least level of deciding the output. This is least level. This is very good level of deciding. First feature, second feature, third feature, fourth feature, fifth feature. So second features and fifth features decides the output very much. So we should take it. If you are interested with the third feature also, you can go with this one, eighth feature, that decides 181.304. So when you reduce the number of features, see, this system is a 8-dimensional data. It is a 8-dimensional data. How we are telling in the sense, see, look at this, how many features are available? 8 features are available. So it is a 8-dimensional data. So look at this. Here it tells you the following way. So you can manually, you can remove. There is another methodology also available. That is said to be the recursive feature elimination. So it recursively removing attributes and building models. So this function is used. Here what you are giving in the sense, recursive feature elimination, your prepared model should be given with how many features you are needing. You can give so that it will tell you. First features, yes, decides. Second feature does not decide. Third feature, no. Fourth feature, fifth feature does not decides the output. And seventh feature, 1, 2, 3, 4, 5, 6. Sixth feature and seventh features decides the output in a higher level. So it provides a ranking also. So look at this. 1 means yes. Here it can be set to be the second, and so on. Okay. So now what we have discussed in the sense, descriptive statistics. Initially, we should load the data, and we are doing descriptive statistics and diagrammatic representation, visualization we did. Afterwards, rescaling the data we did. Afterwards, we did the future selection. Now it is a time to identify how to give the training data. Actually, you are getting the data. How much data we are having? 768 data are there. So 768 data are there. You should give training data and test data. Once the model is created, you need to give the test data. So once the data is taken, the very simplest methodology is go with 60-40. 60% of the data can be given as a training data. 40% of the data can be used for testing. Or sometimes you can go with a gold measure like a 70%, 30% of the data. So the first one is split into train and test sets. The data is there, 768 records are there. You can divide around 60%, 70% of the data. Means that around 550 to 600 data you can straight away give to the algorithm for supervised learning to create the model. See, look at this. They are splitting the data. 67-33. Once the model is created, then the system automatically uses the test data and identify how your model works better. 78.74 accuracy you are getting. What does it mean in the sense, if you are giving the model that you are created is tested with the test data, then when you give 100 records, 79 records it's identify correctly whether he is a PIMA patient, that is a diabetic patient or not. Similarly, k-fold cross validations are there. K-fold cross validation. So here what you need to do is, how many data we are having? 768 data is no. So you can divide into some group. So what I can do is, suppose you k equal to 10 means 768 divided by 10, 76 records a fold. 10-fold you have to create, where each fold consists of 76 records. Suppose you choose k equal to 5 fold, then what you can do is 765 divided by 5. What you can do is 76 152 records each fold consists of. So the well recommended number of fold for any data type in the sense k equal to 5. K equal to 5, k equal to 10. And this k-fold cross validation ensures the data is distributed equivalently. So look at this. The data set is divided into 10-fold. And what the system will do is, it uses 9-fold for training, one-fold for testing. And in this way, we are getting the result of, here, look at this, it produces the results. Accuracy 77.34. 77.34. In the sense, if you, once if the model is created, whenever you give 100 records, it capable of identifying 77 records in a very good manner. Similarly, there is another type is there, leave one out cross validation. Cross validation means that you leave only one record and use all 764 records for training, and one record is for testing, and repeat the process. Very time consuming work this one is. And evaluate using shuffle split cross validation, the extended version of the previous one. Okay, so whenever you develop a model for your machine learning algorithm, there is a metric that will give you the idea about how good your model is. Okay, for our classification problem, there is n number of metrics are there. One is set to be the classification accuracy. This is what we used in the previous case. And another one is logarithmic loss. And another one is area under ROC curve. Another one is confusion matrix. And another one is classification report. The very simplest model is classification accuracy. Okay, let us see. See, what we are doing is, we are getting the data, we are splitting the data, we are creating a model, and we are using accuracy as the evaluation metric, and here it gives the value. Here, accuracy 0.77. Multiply it by 100, it will give you 77%. Then there is another type of metric is that, name it as area under ROC curve. It's a performance metric for binary classification problem. It represents a model's ability to discriminate between positive and negative classes. An area of 1 represents a model that made all predictions perfectly. An area of 0.5 represents a model that is as good as random. So that is also you can use. Here they are using ROC curve as the metric. So let us see what it does. What output comes. A curve comes with the 0.825 is okay, more than 0.5. So it says like the developed model is very good. Okay, there is another type of confusion matrix. This is also one of the metric available, and a classification report also that gives a clear-cut idea about other metric. Here there is something like F1 score, recall, precision, everything is there. Accuracy is the metric we are interested. It gives accuracy. Suppose you want to know about some other metric like a recall, precision, F1 score. This is also there. Precision means how precisely it identifies. Recall, another metric, and so on. Now, let's see about what are the various algorithms are there, how various algorithms works, and what is the accuracy it produces. Okay, first let us use logistic regression classification. So these are all some of the packages that you need to use. This is for k-fold cross validation, for scoring. This is a algorithm that you are going to use, and so on. So we are taking the data and opening the file, and we divide the data into futures as well as the output class, and how that k-fold cross validation, how many folds should be there that we are selecting. And we are using logistic regression as the machine learning algorithm. Then it produces the following output. Its accuracy is 0.77. 0.77. Suppose you are using some other algorithm for this classification, LDA, linear discriminant analysis, then it produces 0.77. Both produces the same output only. KNN classification. This is another machine learning algorithm is available, which uses distance as the metric to classify any two different classes. You can see like 72% only comes accuracy. So this model does not work well for Pima Indian diabetes dataset. Gaussian naive Bayes classification. This is a machine learning algorithm, works based upon Gaussian probability, right? So it produces 0.75% of accuracy. The model is capable of identify 75 records out of 100 records correctly. But the previous algorithm like logistic regression and linear discriminant analysis worked well. Next, CORT classification. This is a tree-based classification algorithm. It produces poor results, like 68% of result. That's poor. SVM classification. This is also provides result like 76% of 1. If you want to work everything all together, then you can do as follows. You can give all the algorithm all together to this models, and you can evaluate it. It will draw the plot for you. See, look at this, the plot that we are getting. This is the plot that we are getting. See, look at this, the data. Linear logistic regression produce 0.77 accuracy. LDA produce 77 accuracy. KNN produces 72. CART 0.69. Naive Bayes 0.75. SVM 0.76. This diagram clearly depicts which works much better. So from this you can identify LDA works much better. See, look at this here, 7734342862. Okay, LDA algorithm works much better, or you can say like both the LR as well as LDA works much better comparing with all other algorithm. So you can choose LDA as a better working algorithm, and you can create a model. Thereafter the model can be used to test the new values. Okay, so we are in the end of the session. Let me recap what are the things we did. What we did. So our title is Machine Learning Algorithm for Big Data Analytics in Smart Grid. Okay, let me recap. I explained about what is power grid. Thereafter, I said what is smart grid and what is the application of the machine learning algorithm we discussed. So machines can learn the data and algorithms responsible for causing faults in the system, and use this information to identify problem before they use. Manufacturers can make use of machine ML to improve maintenance process and enable them to make real-time intelligent decision based on data. So I taught you about what is data. Then I told you about what is big data. And we discussed about where is the source of the big data, what is the problem with the traditional algorithms of big data, what are the characteristics of big data, what is the problem with the traditional algorithms like data mining to deal big data. Then we discussed about phases in big data analytics, where it is used. Then we discussed about the various analytics models comparing with analysis. What is analysis? Analytics model we discussed, and I gave you example from cricket. What is descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics we discussed and explained with each and everything. Thereafter, I discussed about what are the various type of machine learning algorithms are there. Then I gave you about machine learning introduction, machine learning application we discussed. I said about machine learning types, supervised, unsupervised reinforcement algorithms we discussed. We discussed hands-on machine learning algorithm using Python. In this regard, I gave you the explanation regarding Google Colab and why Python is most desirable languages, and the steps that involved in machine learning project development. So I took diaptic patient data set and classified whether the patient, the record is belonging to the affected patient or not. Then these are all the following steps that we used to develop our project. Understand data with the descriptive statistics. Then we discussed with the visualization, that is diagrammatic, bin diagram, so on. We pre-process the data. Suppose if the data is missing anything, we should fill it. Suppose any of the new text data is available, that should also be fixed. Then we discussed about future selection, because not all the futures are going to decide output. So we selected the appropriate feature only. Then we did about how to divide the data into trained data, tested data. That's what a resampling methods we used. Golden rule is go with the k-fold cross validation using k equal to 5 and k equal to 10. Then algorithm evaluation metrics we discussed. The prominent, very simplest metric is said to be the accuracy. Another one is classification report, right? And curve, everything we discussed. And we used a n number of classification algorithm, 5-6 classification of algorithm, and we compared the accuracy with one another, and we come to know about logistic regression, and the LDA works much better. One small thing is, actually for smart grid, if you're having the data set, then you can use the following procedure to build the model, and you can come to the same suggestions. Suppose you are interested to identify that what is the expected load, right? Load from the smart grid for the future, from the next one, you can go with the regression problem. It will tell you about what is the expected load and so on. So this is the step of developing a machine learning algorithm. So I completed my title. I presented in the title machine learning algorithm for big data analytics in smart grid. If you have any questions, you can interact with me. Let's take 5 minutes. Let me ask the host. Sir, I completed my session.
Sir, okay, sir. Thank you,
if
sir.
they are interested, they can ask me the questions.
Participant, do you have any queries? In the sense, you may ask expert. He may answer your queries. Or else you just put it in chat box. He may answer.
No, sir. Kota Sarada. Thank you. Can you explain where machine learning is being applied industry specific to electrical engineering? Okay. The one question. Krishna is asking, can you explain where machine learning is being applied industry specific to electrical engineering? Oh, that thing at the initial way, I told you one thing, like customer demands, sudden changes of customer demands in terms of power, and the power outages, sudden drops, such a things we can easily calculate. Or another one is, from the data set itself, we can identify the problem before we are using. Some other things like manufacturers can make use of ML to improve maintenance process and enable them to make real-time intelligent decisions. See, smart grid in the sense, it not only sends the power, it also sends the data from one place to another place. So wherever it collects something like this place, there is a problem. Here the load is. Here the outlet is. In this way, you can collect the data. Once if the data is collected, by using a machine learning algorithm, you can identify like what is a future load demand will be. Okay. Is it okay, Krishna? Then Amas Deepthi asking a question. Can you send some more info on ML application on finance sector using reinforcement learning? Actually, reinforcement learning is a type of punishment and reward based algorithm. This algorithm is widely used in gaming as well as robot navigation. For finance related thing, I can tell you like traditional supervised learning and unsupervised learning is highly used. For financial, suppose the person is interested to classify the customer is good and bad, right? Straight away what they can do is they can go with the classification algorithm. Once they give n number of customer records, it will identify whether they are a good customer, they are a bad customer, they are the platinum customers. That's what I said in this. From the customer information to retail information to customer behavior, we can do that. So Amas Deepti, more information on finance sector. So this is the finance place where supervised learning is used. Is it possible to apply to fault detection in power system? As a real-time data set, case studies will not be available. How can this be possible? Contrast to this, there are hundreds of research articles available in the literature. Please explain. Krishna, it is very easy to identify that fault detection. Why? Because the definition for smart grid goes as follows. The smart grid not only sends the electricity only. In two-way communication, not only it sends electricity only, it also sends the other data, such as anywhere the fault problem is there, load is there, and so on. Such a things, it sends the data. So if the data once collected, what we can do is we can interpret, we can do the analytics activities that will tell you will any problem come or not, whether the particular place is a problem or not. So this is what a real thing. You should first of all know about power grid. Not only send the power, it also sends the data related fault, how much power is going, what are the areas of problem, such a information all to and fro, it keeps going. So analytics is possible, no? So we can use the systems to identify whether fault occurred, what is the peak demand requirement would be. In this way, we can design a model. So is your question answered? Okay, Amas Deepti. Bits are the markets and pricing were shown in reinforcement learning in your slide. Okay, I think that reinforcement learning also they can use so that they can decide the recommendation system, because there is not only a single model is available for anything. There can be a n number of methodology also they can use. Actually, she is asking about the reinforcement learning. Finance sector. Okay, finance sector. Suppose in the finance sector, in the sense, similar activity can also be done with the reinforcement learning also. Whatever the thing can be, like classify that customers into good customer, bad customer, designing the recommendation system from the data. That also one of the place of a finance sector. Loan prediction. So what will be the future thing? That thing also reinforcement learning is used in the finance sector. So that's what your problem, depending upon your problem, the appropriate algorithm can be used. So reinforcement algorithm in this way used in the finance sector. My problem I told no. Krishna, is any the relay manufacturer industries using machine learning for development of relays? Actually, in the last session, Krishna, Sir said no, IoT is used for IoT smart grid, right? for everything, any related components, you can collect the data. Yes, in industry it is used. That's what I'm telling. Power grid is not only send power electricity to and fro. It also sends all the data related with, that can be a relay or some other electrical components, okay, from one place to another. So this is how they are fixing all the problems. Murunali, yes, Murunali, I will share my PPT and notebook also. Thank you, Krishna. I think you understand. I answered your question. So suggest some data website for microgrid and a smart grid. Straight away, you can Google, or let me, when I send, please make a note of my mail ID. I will, please mail me. I will tell you that a particular place where microgrid and the smart grids related information. Mr. Champanandi, please make a note of my mail ID. You can mail me. I will give you the appropriate data website for microgrid as well as the smart grids. Thank you. Audience, is there any question?
Thank you, Suresh, sir.
Thank you, sir.
Thank you so much for your presentation, sir. Presentation is very nice. Thank you, sir.
Thank you, sir. Thank you, participants, for your patient listening. I would like to thank the ATAL FDP coordinator, head of the department, P.A.College of Engineering Technology principal, management, for giving the wonderful chance. That was a nice session for presenting as well as interact with you also. Okay. Thank you. Thank you very much.
Participants, to note, session 3 will be start sharply by 2 p.m. All are requested to join session 3, where we need to take group photo, and also we will share. We will have validatory function. At the end of validatory function, we will share the Google form, test form, where you need to submit the test form within a stipulated time period. The time extend up to 3:30 p.m. You need to submit all your test forms within 3:30 p.m. There will be only one response. There will be not more than one response. So properly answer the questions. The questions are all from the expert lectures presentation. So kindly cooperate with us. We will close the session by 3:30 p.m. All are requested to join the meet sharply by 2 p.m. Thank you all.